This video is all about a third example of vectors. Using the component method, determine the resultants of the following vectors. For vector A, with a force of 450 newtons with a direction of south 30 degrees west. For vector B, 750 newtons due north. For vector C, with a force of 800 newtons and a direction of north 50 degrees east. Now, the second step after reading the problem is we have to proceed with our solution by drawing the free body diagram or force body diagram. All right, after drawing our force body diagram, for this example, I'm going to explain this figure. If we're going to draw vector A, so since we are given with a direction of south 30 degrees west, so we're going to start from south going 30 degrees towards our west. So this arrowhead represents vector A with a force of 450 newtons and a direction of south going 30 degrees west. For vector B, it has a force of 750 newtons pointing upwards or north. And for vector C, it has a force of 800 newtons north going 50 degrees east. So this is the representation of arrowhead for vector C. Now let's proceed. To determine the result, at first we need to bisect each vector and then determine their respective horizontal and vertical component forces. So I'm going to show a tabular form of solution. So we have a column for forces or vectors, and then their corresponding horizontal forces and vertical forces. So these are the component forces of the vectors. For the vector A, it has this force diagram. So A points downwards. So since it's south 30 degrees west, so this is the 30-degree angle. And then to determine its counterpart or complementary angle, it is 90 minus 30 degrees. So this angle is 60 degrees. Now our analysis will be coming from this angle, which is the complementary for 30 degrees is 60 degrees. Now this vertical force AY, since this force is pointing downwards, its vertical force is pointing downwards as well. So when we say pointing downwards of forces, it is negative. Okay, we're going to base our signage on our Cartesian plane. And if the force horizontal points towards our west or left, it's negative as well. To determine now the horizontal force for this vector A, so cosine 60 degrees gives us negative of its adjacent, which is AX, all over the hypotenuse 450 newtons. Okay. To determine now the AX, to bring out AX, so cross multiply 450 to cosine 60, and then multiply both sides of equation with negative. So this becomes positive AX is equal to negative 450 newtons cosine 60 degrees. Now to determine now the Y or the vertical component for the vector A, since AY is opposite, so we're going to use sine. So sine 60 degrees is equal to negative AY all over our hypotenuse 450 newtons. And then cross multiply 450 newtons to sine 60, and then multiply both sides of equation with negative 1 to bring out a positive AY. So it becomes AY is equal to negative 450 sine of 60 degrees. For the vector B, since it points upwards, or north. So this has zero horizontal force or zero horizontal force component, whereas the vertical force for this vector B is positive 750 newtons since it points upwards. Now for vector C, okay, 800 newtons, north 50 degrees east. So north 50 degrees east. So our 50-degree angle is located in here. To determine now its complementary angle, so 90 minus 50 degrees, this is 40 degrees. And then our analysis will be coming from this axis. So we're going to use 40 degrees. Hence, the horizontal component force for C or Cx, since this is adjacent, so cosine 40 degrees is equal to Cx all over 800. To bring out Cx, cross multiply 800 to cosine 40. So this becomes Cx is equal to 800 cosine 40. And then for our vertical force or vertical component force for component C, this is positive Cy, okay? And then this is opposite, obviously. So sine of 40 degrees is equal to Cy all over 800 newtons. Then to bring out Cy of the equation, so this is Cy is equal to 800 newtons cross multiply sine 40 degrees. The next step is to sum up the horizontal component forces. So AX plus BX plus CX. So negative 450 newtons cosine of 60 plus 0 plus 800 cosine of 40 gives us a sum of 387.835 and 6 newtons for the summation of horizontal component forces. For this summation of vertical component forces, AY plus BY plus CY gives us negative 450 sine 60 plus 750 plus 800 newtons sine of 40 brings up a value of 874.5187 newtons. Now, the next step of the solution, or the next step of this problem to determine the resultant, is to proceed with our resultant force. Now remember, our resultant force is an application of Pythagorean theorem. So R is equal to the square root of summation of f of x squared plus summation of f of y squared. Substituting the values gives us the square root of 387.8356 newtons quantity squared plus 874.5187 newtons quantity squared. Further simplifying the whole equations gives us our resultant forces as our resultant force as 956.6606 newtons. And then for the resultant angle, we're going to use the formula of theta is equal to arctangent of Fy all over Fx, or inverse tangent of Fy all over Fx, or tangent raised to negative 1 of Fy all over Fx. Okay. So substituting now the following values gives us the arctangent or inverse tangent of 874.5187 newtons for the summation of force vertical component all over 387.8356 newtons for the summation of horizontal component forces gives us the final value as 66.0834 degrees.